Hello AP Statistics student. In this video, we will be discussing the many aspects of probability. We are covering how to interpret probability, the law of large numbers, basic probability rules, independence, and how to diagram probability. The probability of an event is the likelihood that it will happen. For example, if you have a 0.5 or 50% probability of something happening, that event will happen half the time. This would be like flipping a coin, where the odds that it lands as heads is 50%, or one out of the two possible outcomes. For any chance event, the set of all possible outcomes is called the sample space S. The probability model shows all outcomes and their probabilities of occurrence. Here is the proper notation for a given event, A. Probabilities are not definite. If you flip a coin twice, you would expect one heads and one tails, since that result is the most likely one. But this is not always the case. Because of this, we use the law of large numbers to make sense of variations from what is expected. We say that as you take more and more samples of the same thing, the results will approach the expected value. If you flip a coin 100 times, you're more likely to get near 50 heads. And if you flip a coin 1,000,000 times, the ratio should be almost exactly 1/2 heads, which is our expected probability. Let's transition to another example, a 6-sided die. Much like a coin where there are two possible outcomes, when you roll a die, you get one of 6 outcomes. Since we cannot roll a die and simultaneously get a 3 and a 5 at the same time, we say that these events are mutually exclusive. Two events are mutually exclusive if they have no outcomes in common. With the die, the probability of getting a 3 and a 5, written as P of 3 and 5, is equal to 0. The probability that 3 or 5 occurs, written P of 3 or 5, is simply equal to the probability of rolling a 3 plus the probability of rolling a 5. This is called the addition rule for mutually exclusive events. For events that can occur together, we have to use a different addition rule. For example, if we have a two-way table diagramming males and females and whether or not they have pierced ears, and we want to find the probability that a randomly selected subject is male or has pierced ears, we need to look at the total probabilities and remove any double counting. The probability of someone being male is 90 out of 178. For pierced ears, the probability is 103 out of 178. To remove double counting, we subtract the probability of being male and having pierced ears, 19 over 178, from the sum of the other two. This gives us a final probability of 174 out of 178 for people who are male or have pierced ears. Now say we have two events that occur from the same chance process and we want to find the probability of both event A and B. To do this, we need to understand what a conditional probability is. A conditional probability is the probability of event B happening given that event A has happened. Using the pierced ears example, say we want to find the conditional probability that someone is male given that they have pierced ears. This event would be written like this. From the table, we can see that the conditional probability is 19 over 103. Now let's return back to the general multiplication formula, which is used for finding the probability of events A and B occurring together. The formula is the probability of event A times the probability of event B, given that event A has happened. Since the probability of having pierced ears is 103 over 178, and the probability of being male given the student has pierced ears is 19 over 103, which we determined earlier, we multiply the two together to find that the probability of being a male and having pierced ears is 19 over 178. There are three types of diagrams for showing probability. A two-way table shows the amount of times each event has occurred. To solve for the probability of an event using a table, you just divide by the total. When calculating the conditional probabilities, you only use the row or column total. A Venn diagram is helpful for showing when event A occurs but not B. The number in circle A is the probability of event A happening but not B. The intersection between both circles is both A and B occurring. Outside both circles is neither A nor B occurring. Finally, we can use tree diagrams. Tree diagrams are helpful for displaying conditional probability. In the example, if you wanted to find the probability of event C given event A, you would simply multiply them together. Thank you so much for watching.